Okay, so continuing on, we have the JPEG or JPEG or JPG, whatever the case may be, and it gets its name from the Joint Photographic Experts Group, which defines a standard for a file type and for other still picture coding. JPEGs allowed for photographs and other color-rich images display as well. So what we see right here is a JPEG, and JPEGs do have, and this comes in at 297 kilobytes, so basically a little over 250,000 bytes of storage there. A JPEG has complementary usage of GIF files. It also works well with storing photographs and other color-rich photos, but a simple image like the logo would be much less efficient use of this image type. So what they're saying is, if like a logo is only using probably basic colors, so if you're going to do that, use something like a GIF, because GIFs are always smaller than a JPEG. A JPEG is highly compressed, which means that a photograph saved as a JPEG will have already been relative small file size. However, if it is a lossy format, whenever a JPEG is compressed or modified, it loses some of that quality. You don't get it back. Compressing the image to a certain point will allow to display well on a web. So site designers often experiment to find the right balance between image quality and file size, which I've talked about earlier. What quality we want as opposed to file size. Okay. This image right here, 6.1, with a blur applied to the background, has a savings of 76,000 or 76K from the original. So they've actually blurred the background and kind of taken some of that quality out of that background, kind of blurred it. What that does is actually save some. If you're looking for ways to reduce file size for JPEGs, blur the background of the image. This technique leverages JPEG's compression algorithms while making a focal part of your image still sharp. When a JPEG is compressed too far, it can result in fuzzy edges and other image distortions. Okay, so for example, we have blown this guy up, and if we could zoom in like we did right here, we can actually see that we did lose some quality. So it's already been compressed, so we try to uncompress it, make it bigger, zoom in, we will actually see this bitmappy color separation, all that kind of good stuff. It says this particular publisher has said, I found a compression rate of 20 to 30% to be sufficient for most photographs. Ratcheting up the compression more tends to bring out too many compressions. So ratcheting means zoom in, make it bigger. Yeah, again, we always want to avoid that. PNGs. A PNG is short for portable network graphics. That provides either an index format, which is like a GIF, except it has more colors, or a full color RGB, which is like a JPEG. So PNGs are kind of like, it's like the best of both worlds. Now, one thing that I don't think I've described yet, but a GIF and a PNG can be transparent, meaning there are parts of that picture that can be transparent so that things behind it can basically show through. JPEGs cannot do that. Both PNGs and GIFs are lossless, meaning that when we compress them and uncompress them, we do not lose any data. So comparing file size between the PNG and a GIF, right? The PNG image weighs in 140 while the GIF is 158. So we're going to actually see more colors and more detail in this picture than we do in the GIF. So if we were to take the colors and band them to and basically kind of look at it's kind of hard to tell here. Let me see if I can zoom in. So here is maximum quality. And we can see that going from a purple to a blue, we don't see too much color separation. We see high quality, we start to see more separation. That's very high quality. We see high quality, we start to see separation. Here's medium, here's low, and here's zero quality. Okay. Now here's 8-bit GIF, a 7-bit GIF, a 6-bit, and a 5-bit, 4, 3, and 2. As you can see, where that really goes. Okay, so and here is a GIF that's been dithered. Okay, dithered meaning we've taken bits away. Here's a 7-bit dithered. Here's a 6-bit. Here's a 5-bit. Here's a 4-bit, 3-bit, 2-bit, 8-bit. Oh, this is a PNG. This is an 8-bit PNG. 765. Here's a 432. Here's an 8-bit PNG dithered. Again, less pixels. 7-bit, 6-bit, 5-bit, 4-bit, 3-bit, 2-bit. Okay, so you kind of see that there's really not much difference between the GIF and the PNG when we basically dither all the way. So if we take a look at an actual picture, again, if we zoom in, so here is a high quality JPEG, a very high quality, a high quality, medium, low, and 0. We can start to see different color separations in this picture. There's an 8-bit GIF, 7, 6, 5. Notice that we starts looking kind of washed out. Here's 4, 3, and then 2. Again, 2 meaning there's only 2 colors. 8-bit GIF dithered, 7-bit dithered, 6-bit dithered, 5-bit dithered, 4, 3, 2. Okay, so there's an 8-bit PNG dithered, 7-bit, 6-bit, 5. Again, we get all the way down to 2. That's only 2 colors. Okay, so here's a compression chart. Here's maximum quality, very high quality. So kind of the same thing. So if we look at these guys. Again, it's probably better to look in your book, but you can start to see where we can start seeing the bit mappiness and that type of thing. And we really don't see a whole lot of difference between these, which is good because if we're trying to save some space on our file, this would be a great one that we can actually compress down and make it dithered and change the polarization. Here's an image compression. Here's JPEG maximum, very high, high, medium, low, 0. Here's an 8-bit GIF. So again, not much difference between the 0 and the high and the maximum in that particular picture. So again, we have to kind of make a test run to see what they basically look like. Here's the 8-bit, 7-bit, 6, 5, 4, 3, and then here's a 2-bit. And again, notice that we do have a dark blue down to a light blue. When we get over here, we just have dark blue, we just have light blue. That's it. Down here, we kind of have a dark blue, a lighter blue, and a light blue, and then it basically kind of goes up from there. We can see all the differences in the dithereds as well. So last thing we'll talk about is this thing called an SVG file. An SVG file is basically a file that's been zipped. It's kind of zipped up. This is so as with a GIF, an index PNG uses dithering to translate a full color image into format. Because full color PNG files are so large, this can provide a reasonable compromise between image clarity and file size. A dithered index PNG remains pixelated, and look at its full color so basically again here's a PNG 8. It only has 256 colors. And as you can see, we can really, when we zoom in, we can really see the separation of colors. And here is the table color that's being used. There's the swatches that are being used. Here we only have, we still have 256 colors. We start to see some reds in the face there. So if we take a look at an SVG file, now an SVG file is a really strange file in that if I were to open it, I'm going to open this with Microsoft Edge, that's what it looks like. No big deal, right? Well, it is, because we can also open this guy. I'm going to open mine in an XML editor. Open it up, and this is what it looks like in an XML editor. So I can come in here and it's got all of these fields that I can go in and change. For example, I can come into this guy right here. I have no idea which field this is, but I'm going to do FF00EE. Okay, that's probably 2. Let's do EE22. So I save this guy, and I go back to the color. I'm going to do a refresh, and oh, look at that. I just changed that piece to yellow. So I can actually go in, and each piece, each part of that picture is laid out in this XML file. I can actually use a text editor to edit this picture file. So it says that scalable vector graphics is a unique image file format that has been around for a while, but has recently been widely adopted by browser vendors, as appearance and behavior as SVG images are defined by text files. They can be edited with a text editor or drawing program. So again, here's the McDonald's logo. Here's what it looks like when we look at it in a text editor. Because SVG images are composed of repeated fragments of XML text, they have a lossless compression. Because I can compress this or uncompress it, that text information does not change. The industry standard for compression is to use a zip algorithm, resulting in a file name ending in SVGZ. The greatest benefits to SVG file is the quality and searchability. So again, since it has text built into it, we can actually do a search on it. Unlike most other image file types, an SVG is not pixel-based, so it can be expanded or reduced without affecting how the picture appears. So again, up close, an SVG image on the right has smoother edges than the same image as a GIF. Okay, notice the sharpness of all of the edges, and over here it's kind of matted. Because SVG files do not rely on pixels to define the image, expanding the file does not result in dotted or jagged appearance like it does in raster images. Expanding the image size is a matter of building XML text to define the parameters. So in conclusion, images enhance the web, making it richer, more visually appealing, and web developers need to know how a common and varied image formats work. Doing so allows us to create complex presentations without inflated image file sizes that can hinder users on slow computers or internet connections. Okay, so next chapter we're actually going to get into creating images with some of the different tools that are out there. So we'll see you next chapter.